In this video, we are going to focus on section 2 of chapter 8, and we're going to take the ideas of real numbers and algebraic thinking, and we're going to focus on expressions with variables. So in the South Carolina standards, a lot of this starts in 6th grade, and you can see that we're looking at numeric expressions and algebraic expressions, and we're starting to look at verbal phrases including variables. So we're going to look at some terminology with that. We're going to look at different words that we can use, and then we're going to take those variables and we're going to use them to represent quantities in real-world mathematical situations and figure out what's the variable mean in this particular context. So if I have h equals the number of horses, what does it mean if h equals 7 or h equals 0? We're going to investigate the relationships because we're going to look now at equations modeling the relationship between independent and dependent variables. Okay, so let's look at some algebraic expressions. So starting off here with these 5 expressions, and we're just going to change this verbal expression into an algebraic expression. That's one of the things we're expected to do in 6th grade. So 2 more than a number. All right, now think about the way this one is phrased. 2 more than a number. That means if I give you a number like 7, you should be able to give me the number that is 2 more than my number. So when you do that, you're going to do 7 plus 2. If I have the number 12, and you're going to be 2 more than my number, you're going to be 12 plus 2. But did you notice that it rearranged? When you have the more than, the number is what comes first, and the addition of 2 comes second. So the variable expression that goes along with this word expression is n plus 2. N here being my variable that stands for a number, and 2 more than that number means I start off with that number and then I increase it by 2. Square root of 2 greater than a number essentially is meaning the same thing as meaning that it's more than a number. So oftentimes when our students see this, they want to put an inequality symbol in there because greater than and less than are the little alligator mouths in their minds. But we need to focus on the fact that if something is 2 greater than something else, it's just like what we had before, and you're just going to increase that value by square root of 2. Again, my variable there, n, representing a number. So more than and greater than, I would tell my students go quote unquote backwards, because this part of the expression comes first when I change it into a variable expression, and this part of the expression comes second. All right, 2/3 less than a number. Well, in more than, less than is the opposite of more than, so it's going to work exactly the same way. I'm going to take my number, and instead of increasing it by 2/3, I'm going to decrease it by 2/3 because I see less than. And so here's what my expression would turn out to be, n minus 2/3. Fewer than would work the same way as this, but essentially in all of those, you're going to be quote unquote backwards. And that's really important for your students to understand. They're going to get the right answer either way with an addition problem, because remember, addition is commutative, but subtraction is not commutative. So it's important that they learn how to do this in the correct order so that they'll get the subtraction problems right. All right, 2 times a number. The product of 2 and a number. Anything like that is going to work out to look like this. So you want to get them out of the habit of doing things like 2 times a number, because once you move into algebraic thought, this becomes the expression 2xn. That x we no longer think of in our minds as being multiplication. That x we think of as being the variable x. So this turns out to be a much better way to write the answer than the 2xn that they might be tempted to write coming out of elementary school. All right, a number times itself. So that's going to be n times n, or n squared. And you notice here they did not use an x, they used a dot, moving away from that x notation because now we're moving into algebra. Okay, so now let's take these statements and move them into algebraic form. So I'm renting a car, and for however many days I choose to rent the car, the charge per day is $40. So I'm going to need to define a variable. I'm going to let my variable be n, which is the number of days that I am renting. And if the charge is $40 every day and I'm going to rent for N days, then I'm going to pay 40 N dollars. N being the number of days multiplied by the charge for every day. Okay, let's look at this next one. The distance a car travels at a constant speed for any number of hours. All right, so this time let's let our variable be h, and h equals the hours traveled. Or maybe you want to say the number of hours traveled. That would work also. So if I go 65 miles per hour and I travel for some number of hours, if I want to know the distance that I traveled, I will multiply those together. So think about the units that I have here, 65 miles per hour. That's the same thing as 65 miles per hour. And then I'm going to multiply that by h hours. And look at what happens. My hours cancel out. And what I'm left with is miles, which is what you can see right there. So sometimes that's a little bit confusing for students. This one is a little bit more obvious. You're actually renting the car for a number of days, and the charge per day is $40. So this is really $40 over days, and I'm multiplying by days. But because we think about cost in dollars already, it makes sense that I would get 40 in dollars. It's not nearly as obvious why when we multiply speed and time, we end up with distance. So showing your students something like this is going to help them understand that formula, distance equals rate times time. Okay, let's look at this one. So I went out to a fast food restaurant with my friend Akiva, and Akiva is on a diet where he can only eat 2,000 calories per day. So French fries have about 12 calories apiece, and a hamburger has about 600. So if he ate one hamburger and F French fries, how many more calories does he have to go for the day? Okay, so let's think about what we have here. First, we need to find out how many calories Akiva consumed after eating F French fries and one hamburger. How many calories did he consume in that one meal? And then to find out how many more calories he can consume, I'm going to need to subtract that from 2,000. I'm going to have to do some simplification there as well. Okay, let's think through that. So one French fry, what did it say to us? How many calories does each French fry have? Well, each French fry is 12 calories. So if I eat F French fries, how many calories will I eat? 12 times F. 12 calories per French fry times the number of French fries gives me calories left over. And again, that's that same idea of thinking through the units that we had on miles per hour, but this one may be more like the dollars where it's a little bit more obvious to your students. Maybe not. Maybe you're going to have to work through that with them, but the idea of F French fries giving you a certain number of calories is a little bit more clear, I think. Okay, so now if I want the total number of calories in my F French fries, which I have here, and also one hamburger. Okay, well, how much was one hamburger? One hamburger was 600 calories, and then we're going to add to that the calories he got from the French fries. What we don't know is how many total French fries he ate. So 12 times the number of French fries he ate plus the $600, I mean, not dollars, 600 calories for the hamburger. Okay, so then if I want the number of calories left, remember we said we're going to take his total amount of calories that he can have per day, and we're going to subtract away how much he's already used. Notice that this subtraction puts this in parentheses. I don't want to subtract 600 and then go back and add 12F, right? I'm not increasing the number of calories he's allowed by the number of French fries he ate. I'm decreasing it by the number of French fries he ate. So it's important that this is in parentheses. That will help us to remember to distribute our negative because we want to subtract away the calories for the hamburger and also subtract away the calories for the French fries, however many French fries he ate at 12 calories apiece. And then if I simplify this expression, I can see that these two are like terms. And so this will simplify to be 1,400 minus 12F and that's how many calories he has left. So the units on that would be calories.